Do you live in Ecuador? Do you live in the Napo province, in the province of Sucumbíos, in the Quijos Valley, in the town of El Chaco, in the village of El Reventador itself, or anywhere in the eastern Andean foothills where the jungle meets the cloud forest and the trans-Ecuadorian oil pipeline threads through the landscape below an active volcanic cone? If the answer is yes, you need to watch this full video, because the volcano that looms above that landscape has spent the past 10 days producing one of the most sustained and relentless explosive sequences it has logged in months. And the numbers coming out of Ecuador's National Geophysical Institute right now are not numbers that anyone living downstream of this mountain can afford to ignore. Between June 29th and June 30th, 2026, Ecuador's Instituto Geofísico, the Escuela Politécnica Nacional, abbreviated IG-EPN, and the agency responsible for monitoring every active volcano across the entire Andean Republic, reported that Reventador logged 67 seismically detected explosions in a single 24-hour period. 67. That is not background activity. That is not routine degassing from a volcano that is technically still erupting, but essentially sitting still. That is approximately 3 discrete explosive events every single hour, sustained continuously across a full day and night, each one large enough for the seismographs positioned across the network surrounding this cone to record a distinct signal, each one producing an outward signature of gas, ash, and fragmented rock that instruments can track and classify individually. And crucially, that 67 explosion day did not arrive in isolation. It was the middle entry in a 5-day sequence that began with 75 explosions on June 28th to 29th, declined slightly to 67 on June 29th to 30th, then to 64 on June 30th to July 1st, then climbed again to 72 explosions between July 1st and July 2nd, before the Volcanic Ash Advisory Center in Washington issued advisory number 2026-671 on July 8th, confirming that ash emissions from Reventador were still reaching 14,000 feet, 4,300 meters above sea level, drifting westward across the Ecuadorian sky. This next part matters, and it is the context that every headline about this volcano tends to skip over entirely, because Reventador's behavior in late June and early July of 2026 is not something that can be evaluated honestly without understanding what this specific volcano is and what it has been doing continuously for the past 18 years. Reventador is a stratovolcano, a steep-sided cone of layered lava and ash, standing 3,562 meters, or 11,786 feet, above the dense cloud forests of the western Amazon basin in northeastern Ecuador. Its summit sits almost precisely on the equator, 0.08 degrees south of zero latitude, making it one of the most equatorially positioned major active volcanoes anywhere on Earth. It belongs to the Cordillera Real, the easternmost chain of the Andes, set well east of the principal volcanic axis that runs through most of Ecuador's other major volcanoes, including Cotopaxi and Tungurahua. Reventador rises above a 4-kilometer-wide caldera, whose eastern wall is dramatically breached, opening toward the jungle and river valleys below. Within that caldera, a younger, steeper cone has been constructing itself for thousands of years, building up and partially collapsing, building again, a geologically restless cycle of growth and destruction that defines the character of this particular volcanic system more than any other single feature of its landscape. Here's why this is serious beyond the explosive count alone. The current eruption at Reventador began in July 2008, and it has not stopped. As of July 2026, this single eruption has now lasted 18 consecutive years, making it one of the longest continuously running eruptions in Ecuador's documented volcanic history. During that span, the Smithsonian's Global Volcanism Program has cataloged the eruption as producing ongoing moderate to occasionally intense activity, characterized by daily seismicity, including explosions, long-period earthquakes, harmonic tremor, and emission signals, alongside regular gas and ash plumes, periodic lava flows on the northeastern flank, incandescent rockfall avalanches descending the flanks by hundreds to over 1,000 meters, and occasional pyroclastic flows on the steeper southeastern sections of the cone. The activity level fluctuates. Some weeks are quieter, with only a handful of explosions per day and ash plumes barely clearing the summit. Other periods, like the one that just produced 67 to 75 explosions across multiple consecutive 24-hour windows, represent the more energetic extreme of what this continuously erupting system can produce. Ecuador's National Disaster Management Agency, the Servicio Nacional de Gestión de Riesgos y Emergencias, known as SNGRE, has maintained the alert level for Reventador at orange, the second highest level on Ecuador's 4-color scale, essentially without interruption through much of this sustained eruptive period. One more thing you need to know about the specific character of these explosions and what they produce in the immediate environment around the volcano, because the seismic count alone does not fully communicate the physical reality at the surface. The ash and gas plumes rising from Reventador's vent during this recent explosive sequence have been reaching as high as 800 meters, roughly 2,600 feet, above the summit itself on more active days, placing their tops somewhere around 13,000 to 14,500 feet above sea level when combined with the volcano's own elevation. The Volcanic Ash Advisory Center in Washington, which operates the Global Aviation Ash Hazard Warning System and monitors satellite data from GEOES-19, the Geostationary Operational Environmental Satellite positioned to watch the Americas, has been issuing continuous advisories for Reventador throughout this period, tracking ash emissions reaching flight level 140 to flight level 150, that is 14,000 to 15,000 feet, and drifting primarily westward toward the Andean Valley and the capital Quito. On active days during this sequence, incandescent blocks and rockfall material have been observed rolling 800 to 1,000 meters or more down the flanks in multiple directions, glowing on the night webcams like streams of red coal sliding through the dark. Lava has been periodically active on the northeastern flank of the cone, the same direction toward which the caldera wall is most dramatically breached, and which offers the most direct path downslope toward the river valleys below. But that is not the real story, not the whole story, because to understand what 67 explosions in 24 hours means in the specific geography where Reventador sits, you have to understand what runs directly beneath this volcano and through the valleys below it. The Trans-Ecuadorian pipeline system, the critical oil infrastructure that carries crude petroleum extracted from the Amazonian oil fields eastward toward the Pacific coast, runs through the Quijos River Valley directly in the hazard zone of this volcano. During the November 2002 eruption, the single most significant eruption Reventador has produced in modern times, lava flows and pyroclastic flows destroyed roads and damaged the very highways linking Quito to the oil fields of Lago Agrio. The Trans-Ecuadorian oil pipeline was shut down as a precautionary measure while Reventador's eruption column climbed 16 to 17 kilometers into the sky. The ash cloud swept over the Andean divide, and the capital Quito, 100 kilometers away, fell into near total darkness in the afternoon as the ash plume blotted out the sun. A layer of fine gray ash between 3 and 5 millimeters thick settled across Quito's streets, its airport, its neighborhoods. The international airport closed. The government declared a local emergency. 22 people from the communities closest to the volcano were evacuated. 2 people were seriously injured by falling to fro. And the volcano that had produced that catastrophe on November 3rd, 2002, after 26 years of relative quiet, has now been erupting continuously for 18 more years, producing, in the most recent 24-hour cycle with comprehensive reporting, 67 separate explosive events in a single day. Most people outside Ecuador are missing the profound irony embedded in this volcano's basic situation, and it is worth dwelling on for a moment because it shapes everything about how the risk here should be understood. Reventador sits in one of the most densely remote and jungled sections of the entire Andean volcanic arc. The cone itself is not easily visible from the road on most days, shrouded in cloud forest and equatorial rainfall that makes direct visual monitoring difficult and unreliable. The communities closest to the volcano, the small village of El Reventador on the western caldera rim and the town of El Chaco, approximately 35 kilometers to the southeast, are modest-sized settlements whose residents live with the daily sonic reality of this mountain in a way that no one in Quito 100 kilometers away can fully appreciate. The explosions that generate seismic signals strong enough to register on IG-EPN's monitoring network are explosions that residents within a few kilometers of the summit hear as physical percussion, as waves of concussive air pressure that residents of El Chaco have described during past active periods as sounding like distant cannon fire rolling across the valley. 67 of those in a single day is not an abstract seismological statistic for the families living within hearing range of this mountain. It is a day defined by the sound of the earth venting pressure hour after hour without pause. Here is why this is serious for the specific hazards that characterize this volcano's most dangerous moments. Reventador's typical eruption style is described by volcanologists as both explosive and effusive, meaning it produces both violent fragmentation of magma and quieter outflows of lava at different moments, sometimes simultaneously. The most dangerous single hazard it generates beyond the immediate summit zone is the lahar, the volcanic mudflow that forms when pyroclastic material, ashfall, or lava interacts with the intense tropical rainfall that is essentially constant in this section of the Ecuadorian Amazon. Rainfall frequently produces lahars in the valleys below Reventador that have accumulated a large debris plain on the eastern caldera floor across the volcano's geologic history, according to the Smithsonian's assessment of this system. These lahars can travel far faster and much farther than lava flows, channeling through river valleys at speeds of 20 to 40 miles per hour and carrying boulders, logs, and volcanic debris capable of destroying bridges and roads, with essentially no warning to anyone downstream who does not have direct line of sight to the summit. The combination of equatorial rainfall and continuous explosive activity that characterizes Reventador in its most active phases makes lahar hazard here a near constant feature of life in the Quijos Valley. Not a rare catastrophic possibility, but a recurrent operationally significant risk that emergency managers and pipeline operators in this region have to account for as a matter of ongoing routine. And now it gets worse in a specific compounding way that the most recent activity sequence illustrates clearly. The 67 explosion day on June 29th to 30th was not the peak of this particular sequence. It was the second most energetic day in a 5-day window that saw the daily explosion count range from 64 at its lowest to 75 at its highest. What that range demonstrates is that the volcano was not simply producing a single dramatic spike before settling down again. It was maintaining an elevated plateau of explosive activity across most of a week, with day-to-day variation within a band that all sits well above what IG-EPN characterizes as minimal background behavior. Meanwhile, VASI Washington ash advisories continued issuing through July 5th, July 6th, and July 8th with essentially unchanged language, confirming ash emissions reaching 14,000 feet and tracking ash clouds drifting northwest and west at 15 to 20 knots across the aviation routes connecting Quito to destinations further east and south. Advisory number 2026-671, issued at 21.26 UTC on July 8th, was the 671st volcanic ash advisory issued for Reventador in 2026 alone. 671 separate aviation ash alerts in the first 189 days of this calendar year, an average of more than 3.5 advisories per day, every day, without exception, since January 1st. This is where it becomes dangerous to treat this volcano as simply another tropical mountain doing what tropical mountains do. The aviation hazard from Reventador is real, well documented, and continuous. Volcanic ash at the concentrations Reventador regularly produces in its more active periods can cause catastrophic damage to jet aircraft engines, eroding turbine blades, and causing them to fail without warning. The 1982 encounter between a British Airways Boeing 747 and an ash cloud from Indonesia's Galunggung volcano, during which all 4 engines temporarily flamed out before the aircraft descended into clearer air and managed to restart its engines and land safely, remains the canonical near disaster that drove the development of the modern volcanic ash advisory center system that now monitors Reventador from orbit around the clock. Every VAAC advisory that Washington issues for this volcano, including the 671 already issued this year, represents the direct operational legacy of that lesson, applied in real time to a volcano that has not stopped producing the raw material for exactly that hazard since July 2008. Now the focus shifts to what the sustained activity over the past 10 days tells scientists about where Reventador's eruption stands in its current cycle. The Global Volcanism Program's historical record for this eruption documents that periods of heightened explosive activity, like the 67 to 75 explosion days of late June and early July 2026, have regularly punctuated the broader 18-year eruption at intervals of weeks to months, typically associated with periods when fresh magma is moving actively within the upper conduit of the volcano, producing the harmonic tremor and long-period earthquake swarms that accompany explosions in IG-EPN's daily monitoring reports. These swarms are evidence that magmatic fluid is oscillating within volcanic plumbing, the seismic equivalent of the rhythmic vibration of fluid in a pipe under pressure, a characteristic signal of an active, open conduit volcanic system where molten rock and volcanic gas have relatively unobstructed access to the surface. The transition from a period of lower activity, where daily explosion counts may drop into the single digits or low tens, to the kind of sustained 64 to 75 per day window that just passed, typically signals an increase in the rate of magma supply reaching the upper conduit, producing more frequent and more energetic fragmentation events as gas-rich magma pushes toward the surface in greater volume. Most people are missing the depth of Reventador's historical eruptive record and what it reveals about this volcano's capacity for sudden escalation. The 26-year dormancy between 1976 and 2002, the long quiet that made the November 2002 eruption so shocking and so destructive, was not unique in this volcano's documented history. Reventador's confirmed eruptive record since 1541, when the first historical accounts of its activity were recorded, shows a pattern of periodic intense eruptions, followed by gaps of years to decades, then renewed activity, then another escalation, then another gap. The current 18-year continuous eruption, the longest in that historical record by a significant margin, has maintained an essentially open conduit since 2008, meaning fresh magma has had uninterrupted access to the surface since November of that year. An open conduit is, in volcanological terms, a double-edged situation. It means the volcano continuously bleeds off pressure through small and moderate explosions, reducing the likelihood of the kind of catastrophic pressure buildup that preceded the 2002 eruption during the long dormancy. But it also means the volcano is permanently primed, in the sense that any increase in the rate of magma supply from depth can translate quickly into surface activity without the significant pressurization period that builds during dormancy. One more thing you need to know about the specific numbers in the current activity sequence, because they sit within a well-documented range for this volcano that provides important scientific context. The late June 2026 sequence, with its peak of 75 explosions on June 28th to 29th, falls within the upper portion of this documented range, rather than beyond it, which is an important distinction. This is not Reventador doing something it has never done before. It is Reventador doing something it has done before, at the energetic end of its typical variability range, sustained across multiple consecutive days, in a way that elevates the hazard for downstream communities and aviation routes, without yet crossing the threshold into genuinely exceptional anomalous behavior relative to its own well-documented history. That distinction matters for how emergency managers and infrastructure operators in the region calibrate their response, but it does not diminish the real, practical significance of 67 explosions in 24 hours for anyone living or traveling in the zone of potential impact. The historical comparison that most directly illuminates what this volcano is capable of when conditions align goes back to that November 2002 eruption, and it bears repeating in detail because the contrast between routine elevated activity and a true escalation episode at Reventador is as dramatic as almost any other volcano-to-volcano comparison in the Americas. On November 3rd, 2002, after 26 years of essentially no recorded activity, Reventador went from quiet to catastrophic in hours. By 9:12 in the morning local time, the main eruption phase had produced an ash column rising 16 to 17 kilometers above the summit. 3 to 4 hours later, that ash cloud reached the Andean Valley in Quito. Pyroclastic flows raced 8 kilometers down the flanks from the breached caldera. Lava flows destroyed roads and damaged the critical pipeline infrastructure linking Quito to the oil fields. 2 people were seriously injured. 22 were evacuated. Ecuador's government declared an emergency. The international airport closed. And Quito, a capital city of well over 1 million people, experienced near total darkness in the late afternoon from the ash cloud. A volcanic night imposed in the middle of an ordinary November afternoon. That was the single most severe day Reventador has produced in modern times, a reminder that this particular volcano, remote as it appears on a map, is capable of reaching Ecuador's capital and disrupting the entire country's petroleum infrastructure in a matter of hours, when its activity escalates beyond the moderate, sustained level it has maintained throughout the 18-year current eruption. This is where it becomes dangerous to become complacent about a volcano, simply because its elevated activity has been sustained long enough to feel routine. One of the most consistent findings in volcanic hazard research is that community and institutional familiarity with a constantly active volcano can paradoxically reduce preparedness, a phenomenon sometimes called the normalization of volcanic risk, where the daily explosions, the occasional ashfall, the recurring VAAC advisories, the periodic LAHAR warnings, become so embedded in the background of daily life that the distinction between ordinary elevated activity and a genuine escalation signal becomes harder to recognize and respond to with the same urgency it would command if the volcano had been quiet for years or decades before suddenly becoming active. Reventador has been active for 18 years. The communities near it have lived with its daily soundtrack of explosions and ash plumes for nearly 2 decades. The pipeline operators in the valley below have incorporated its activity into their operational risk management for 18 consecutive years. The VAAC in Washington has issued an average of multiple ash advisories per day for 18 years. And yet, November 3rd, 2002, is a reminder that this exact volcano, in exactly this configuration, has previously gone from background noise to national emergency in less than a single morning. The atmosphere around Reventador right now, as of this July 10th update, is one of sustained, well-monitored, elevated activity that has not yet crossed any of the thresholds that would trigger escalated emergency protocols under Ecuador's current alert framework. The orange alert level maintained by SNGRE reflects the ongoing nature of this eruption as a persistent hazard, requiring continuous attention and operational precautions, without yet reaching the red alert level that would indicate an imminent large-scale eruption posing direct, immediate threats to populated areas. IG-EPN's monitoring network continues issuing daily reports, tracking each explosion count, each ash plume height, each incandescent rockfall distance, each SO2 emission measurement that comes off the summit. The VCAC in Washington continues issuing its advisories, pulling satellite data from GOES-19, consulting numerical weather prediction models, and publishing ash cloud forecasts that aviation operators across the region use to make real-time routing decisions. We will know more as IG-EPN continues its daily monitoring bulletins through the coming week, and as the Smithsonian's Global Volcanism Program publishes its next weekly activity report for this volcano. But right now, this needs to be taken seriously by anyone living in the communities near Reventador. by infrastructure operators managing systems that run through the valleys below it, and by aviation authorities monitoring flight paths across the Ecuador and Colombian airspace, where this volcano's ash has the most direct operational impact. The 67 explosions recorded between June 29th and June 30th were not the beginning of this elevated sequence, and the most recent VAAC advisory issued on July 8th was not its end. Reventador has been erupting without pause for 18 years. It spent the final days of June and the opening days of July reminding everyone in its vicinity, from the villagers of El Chaco, who hear each explosion as thunder, to the satellite operators in Washington, who track its ash plumes from space, that this is a volcano that does not wait for anyone to be ready before deciding to turn up the volume.